Hey there folks, Mr. G here with another educational video. This time we're going to talk about how we would graph rational functions. Before we get into graphing them, I think it's important to define what sort of functions we're looking at. When it comes to a rational function, it's any polynomial divided by any other polynomial. That's the definition. One important thing to think about when we have these rational functions is our domain, and that's all of the x values we're allowed to have. For a rational function, all of the x's are fine, except where we have restrictions, which is when our denominator is equal to 0. From our video last time, what we saw is that where we have these restrictions, and in this case at x equals 7 and 0, we have our function either shooting up or down, and I told you they had a fancy name. These are called our asymptotes. In particular, we see vertical asymptotes, and vertical just means they're going up and down. So our boundary here is a straight line up and down. If we start with a really simple rational function, 1 over x, we see that we've got a vertical asymptote right in the middle. That's where x is equal to 0. This line x equals 0 goes right in the middle. It's like a boundary in the middle of our function here. And our function will never touch this line, because when it does, it goes off to infinity, it's undefined, we can't graph it. But it can get really, really close. We have another asymptote here as well, and that's a flat one. Notice how this line on both sides never touches our x-axis, so we have a horizontal asymptote of y equals 0. So these would be our two asymptotes. What about for this function here? 2 minus x over x minus 1. It looks like we've got a vertical asymptote right here, right around x equals 1. Yep, that seems to fit. And then it looks like we have another horizontal one, but now it's down here at y equals minus 1. And that seems to fit nicely there as well. Notice that our function never touches these asymptotes. Now you might be wondering, if I don't have Desmos, how am I supposed to find out where these asymptotes are? For our vertical asymptotes, we already figured this out. It's where our denominator is equal to 0, and it's where our y value for our graph is going to shoot up to positive or negative infinity. And the equation for our vertical asymptote is always x equals something. For our horizontal asymptotes, it's helpful to look back at our graph. We'll notice these horizontal asymptotes occur when we go to really large positive or really large negative x, basically on the far left and right of our graph. To find our horizontal asymptotes, we look at the ratio of the largest degree terms on the top and the bottom. So basically, whichever term has the biggest power of x. We simplify it, and then we imagine what would happen as x goes to some really big number. The answer for this is always going to be y equals something, because our horizontal asymptotes are always flat. Flat lines are y equals something. It's also important to mention that just because it's a rational function doesn't mean it has an asymptote. It might have one type of asymptote, it might only have the other type. It could have no asymptotes, it could have 10 of them. It really depends. Let's go through a few examples. The first one here, we want to find all the asymptotes, horizontal and vertical. To start with our vertical asymptotes here, remember we're looking for denominator to be 0. Notice this is a difference of squares, so we can actually factor this, which tells us that our vertical asymptotes are going to be at x equals positive 2 or negative 2. So those are our two vertical asymptotes. For our horizontal asymptote, we look at the top and the bottom and find the largest degree term for each. On our top, we just have a 1, so for our horizontal asymptote, we're just looking at the 1 on top. For our bottom, the largest degree is x squared. For our horizontal asymptote, we're focusing on 1 over x squared. Then we want to think about, as we put in like a really big x value, some really big number, what's going to happen? Well, we have 1 over a big number squared, which tells us that 1 over x squared is going to go close to 0. So as we plug in bigger and bigger numbers, this is going to be closer to 0. So our horizontal asymptote is going to be at y equals 0. That's what it's going to approach as we go to big x values. When we plot this on Desmos, we can see our two vertical asymptotes here at 2 and negative 2, and then our horizontal asymptote at y equals 0. I also want to take this opportunity to introduce a bit of terminology that the workbook uses and is very common, especially when you get to calculus. On the right side here, we can see our function goes all the way up to positive infinity. On the left side, we're going down to negative infinity. The notation that we use for that is saying that as x goes closer to 2, on the left, we're going close to infinity, and on the right, y is going closer to negative infinity. The way that we say on the left versus on the right, we have a little positive up top here, and on the left, we have a little negative up top here. What this means is that when x is a little bit bigger than 2, we're getting a very close to a big positive number. And when x is really close to 2 but just a little bit less, we end up with a really large negative number. So what happens to our y values when we go close to our other vertical asymptote. When we go to this asymptote here, if we're a little bit less than -2, we're going to positive infinity. If we're a little bit bigger than -2, we go to negative infinity. So on the right, it's negative infinity. On the left, it's positive infinity. So on the right here, we're going to negative infinity. On the left, we're going to positive infinity. We can also do this for our horizontal asymptote, which is when x is going to positive infinity or towards negative infinity. When we go towards positive infinity, we're going close to 0, but we're a little bit bigger than 0. The way that we write that is that y is going to 0, but it's a little bit bigger. When we go to negative infinity, we get the exact same thing. Y goes close to 0, but just a little bit bigger. How about this example here? Let's see if we can find the asymptotes. Our vertical asymptotes, we're just looking where our bottom is 0, so x equals 3. For our horizontal asymptotes, we're taking the largest power of x on the top and the bottom and seeing what it gives us when we set x equals to infinity. The largest power of x on top is x squared, and it has a 2 in front, so we put 2x squared. And our bottom, the largest power of x is just x here. We simplify to get 2x, and then as x goes off to some big number, what happens to 2x? In this case, it would also go to some big number, right? 2 times a big number is also a big number here. Since it doesn't approach a value, there are no horizontal asymptotes, only our one vertical asymptote. When we graph this in Desmos here, we can see our vertical asymptote pretty clearly, splitting our graph in half here, but there's no horizontal asymptote. Our graph just shoots off to infinity in both of these two directions. It doesn't approach a value as we go to bigger and bigger x, it just shoots off. So there's no horizontal asymptote. For our last example here, if we want to find our vertical asymptotes, we want to find where this bottom is equal to 0. If you try and factor this, what you'll find is that there's no values here where this is going to be equal to 0. This can't be factored. Because it can't be factored, there's no values of x that will make this 0, so there's no vertical asymptotes. For our horizontal asymptote, we're going to take the ratio of our biggest term on the top and the bottom. So these two right here, when we simplify, we get 5 over 2. So as x goes off to some big number, 5 over 2 just goes to 5 over 2. There's no x value that affects this, so this is going to be our horizontal asymptote. Y equals 5 over 2. When we graph this on Desmos, we see a weird sort of V shape in the middle, and we can see our horizontal asymptote as x goes to some big positive or negative number, we get closer and closer to 5 over 2. Using our knowledge of asymptotes, we can now put it all together and see how we would graph this without using Desmos. Our first step is to find all of our vertical asymptotes and horizontal asymptotes and then put them on our graph. This will sort of form a framework for our graph that we can use to help draw the rest of it. Next, we'll find all of our intercepts, our x and y intercepts, and plot them as well. Again, this will give us more hints about what the shape of our graph will look like. Next, we'll use a calculator to see what happens when we go near each asymptote. And this will be a little bit clearer when we actually do the examples. Once we have all of this, we should be able to connect all of the information that we have using smooth curves. There shouldn't be really any straight lines here. Almost all of our graphs have sort of a flowy, curvy shape to them. So this is our first graphing example. If you remember, the first step we want to do is try to find our vertical and horizontal asymptotes. To do that, we're going to need to factor our bottom here. -2 and +1 are the numbers we need to use, which tell us that our two vertical asymptotes are going to be at x equals 2 and -1. For our horizontal asymptote, we're going to look at the ratio of our biggest degree terms on top and bottom, and as x goes to some big number, we'll see that 2 over x squared is going to go towards 0. 2 divided by some giant number gives us 0. So our horizontal asymptote will be that y equals 0. Using that information, we can start to assemble our graph. We can label and plot both our vertical and horizontal asymptotes, and this sort of gives us a frame around which we can build our function. Our next step is to find our intercepts. If you remember, our y-intercept is where we set x equals 0, which we can get is -1, so our y-intercept is x equals 0, y equals -1. And there it goes right there. To solve for our x-intercept, we want to solve this rational equation where our function is equal to 0. In this case, we can multiply both sides by x squared minus x minus 2, and what we'll end up with is that 2 is equal to 0. Since this has no answer, there's no way we can make 2 equal 0, there are no x-intercepts. The last step is to figure out what's happening around our asymptotes. And to do that, we're going to use the notation that we used last time. So let's focus on this asymptote right here, and let's see what happens as we go close to x on the right and on the left. Now I mentioned that we're going to use our calculator here. The way that we're going to do that is by plugging in some number that's just a little bit bigger than 2. Say for example, x equals 2.01. Then we take this and we would plug it in to our original function right here. When we plug it into our original function, what we get is a really big positive number. So that tells us that as x approaches 2 on the right, we go to some big positive number. In other words, y goes off to infinity. On the left-hand side, we can do something similar. Pick an x value just less than 2, plug it into our y, and we'll get a large negative number. That tells us that y goes off to negative infinity. We can now draw this on our graph. When x is a little bit bigger than 2, it's going to be really close to infinity here. And when x is a little bit less than 2, it's going off to negative infinity. So those are two parts of our graph that we can fill in. We can do something similar for our other asymptote on the right and on the left. Choose appropriate numbers that are very close to -1, plug them in, and see what happens to our y values. As we see on the right-hand side, we're going off to negative infinity. So we have a line like this. And on the left-hand side, we're going off to positive infinity. So we have a line like that. Lastly, we need to deal with our horizontal asymptotes. So when x goes off to positive infinity and as x goes off to negative infinity. For this, just pick a big x value and plug it in. In this case, we plug it in, we get a small positive number, and we get the same thing when we go off to negative infinity. We can draw that on our graph like this, both just a little bit bigger than our x-axis. Once we have all of these lines, we want to connect them with smooth curves. So I'll connect this curve down here like this, connect this one going through our x-intercept, and connect this one over here. And there we go. There's our final graph. Finally, it asks for our domain and range. To find our domain, we just look and see what x values aren't allowed. So as we scan across here, we see we have no x values at x equals -1 and x equals 2, but everything else in between is fine for our x values. So that would be the answer for the domain. For our range, we'll do the same thing, sweeping from the top to the bottom. We see we're not allowed any y values here. Then we also have a gap here between this line and the start of our little U shape at the bottom here. Now you wouldn't be able to tell from the graph here. You would have to do a little bit of calculus in order to figure out where this minimum point is. So I'll just give it to you in this case. The minimum in this case turns out to be at -8/9. That's the bottom of our U shape here. So our range in this case would be y bigger than 0 and y less than -8/9. This is our last example. We want to again graph this one with all of our asymptotes, intercepts, and everything in between. To find our vertical asymptotes, we're going to have to do a little bit of factoring, but we don't actually care about the top. All we care about is the bottom here. Our vertical asymptotes would be at 0 and -2. For our horizontal asymptotes, we're going to take a ratio of our biggest degree terms on the top and the bottom. Once we take this ratio, it's 1. So if we set x equals infinity for 1, it's just 1. So our horizontal asymptote is at y equals 1. We can sketch out on our graph here. We've got our horizontal asymptote at y equals 1, and two vertical asymptotes at 0 and -2. From here we can find our intercepts. For our y-intercept, we want to set x equal to 0 in our equation here. But what you'll notice is that we actually end up with a dividing by 0 error. And that means that this isn't possible. There is no y-intercept. For our x-intercept, we're going to solve our whole equation is equal to 0. In this case, we can multiply both sides of our equation by our denominator. That'll cancel this out, and when we multiply this on the other side, it's just times 0, so this whole thing is going to stay as 0. And to solve this, we need to factor, which if you do, will give you x minus 4, x plus 1. So our x-intercepts will be at 4 and -1. And we can put those on our graph. Finally, we need to figure out what happens near our asymptotes. Let's start with x equals 0. When we look at our asymptote at x equals 0 on the right side, pick some number just to the right of 0, like 0.01, and we'll get a y value of -200. That tells us y is going off to negative infinity. If we do the same thing on the left here, pick a small negative number like 0.01, we end up with a large y value, so y is going off to positive infinity. We can do a similar thing for our other asymptote here and find out where it goes off to positive and negative infinity. We can also do this for our horizontal asymptotes, so where x goes off to positive or negative infinity. And we can see that y is either slightly above our asymptote at 1 or slightly below it. Adding all that information to our graph, first our asymptote here. On the right, we're going off to negative infinity, so we have this line right here. On the left, we're going off to positive infinity, so this line right here. For our second asymptote, on the right, it's negative. On the left, it's positive. So we could add these two lines right here. And for our horizontal asymptotes, as we go to the far right, we're just below 1, far left, we're just above 1. So we can add these two lines. And at this point, we can just start connecting them. And we end up with our graph right here. This line in the middle is kind of hard to draw, but it shouldn't be a straight line. There should be a bit of a curve to it. On the actual graph, it looks a little bit more like this, with sort of a flatter bit in the middle, but it's not a straight line. Finally, for our domain and range, we look at what x values and y values aren't allowed. For our domain, we see that we can't have any x values equal to -2 or 0. For our range, starting from the top sweeping down, we see we have an asymptote in the middle here, but you'll notice that only applies to the far left and far right. In the middle, we do have something that passes through y equals 1. So this isn't excluded from the range. There is a possibility that we have a y value equal to 1, and in fact, we can have any y value in this case. That's the end of our video on graphing rational functions. Stick around for our last video, which is all about solving rational word problems. See you then.